Ladies and gentlemen, a very good morning and a warm welcome for the Technical Session 2, Department of Pharmacy, Faculty of Allied Health Sciences of the 16th International Research Conference of General Sir John Kotelawala Defence University, which is themed Achieving Resilience through Digitalization, Sustainability and Sectoral Transformation. And this session will be based on the researches done in the field of pharmacy. For the motherland forever is what we at KDU believe in. Ladies and gentlemen, in order to pay our respect to our alma mater, let us now rise for the KDU anthem. Will be chaired by the Senior Professor in Chemistry, Professor R.M. Pathirana of the Department of Pharmacy, Faculty of Allied Health Sciences of General Sir John Kotelawala Defence University. He will now be accompanied to the stage by Dr. A.M. Abeysekera. Now, I would like to cordially invite the Head, Department of Pharmacy, KDU, Dr. H.M.A.J. Halakon, to have you a brief introduction of the chairperson of the today's session.
Okay, very good morning, ladies and gentlemen. It is my privilege to give the brief introduction about our today technical session. Chairperson, Senior Professor Pathirana. So, Professor Pathirana received his primary and secondary education at the college, both and the college Column. He is obtained his BSc degree from the University of Vera and his MSc degree in the phytochemistry and PhD in organic chemistry both at the University of the Southampton, United Kingdom. He was the chair professor of chemistry at the University of Cooray, and upon his retirement he was awarded the title Professor Emeritus from the University of Cooray. He joined the Faculty of Allied Health Sciences at John Kotelawala Defence University in 2013. And recently served as the Senior Professor of the Chemistry at the Department of Pharmacy. He is mainly involved in the teaching medicinal chemistry, pharmaceutical chemistry, and the general chemistry for pharmacy and medical laboratory sciences degree programs. He also served as a visiting lecturer for the later degree programs at the Faculty of Health Sciences, University of Cooray. Actually, presently he is involved in research related to the pharmacology biological active natural products from the medicinal herbs. In addition, he serves several committees appointed by the faculty board of Aqueous. During his career, he has supervised many postgraduate research students and co-authored over 50 peer-reviewed high-impact scientific publications and reviewed 8 textbooks. Also, he has made contributions at the many international conferences. At University of Cooray, he has held many administration positions, such as the head of the Department of Chemistry for over 6 years and the Dean of the Faculty of Science for the several occasions. He served the Council of the University of Cooray and the Open University of the Sri Lanka as a member appointed by the UGC from the 2015 to 2019. He was a visiting research fellow of the University of the Birmingham and a postdoctoral research fellow at the University of the Southampton, United Kingdom, during the period of the 1989 to 1992. He was also a visiting research fellow, a visiting professor, and a senior academic visitor of the University of the Cardiff, Wales, UK, during this period 1998 to 2000 and 2010 to 2011. His work mainly involved the synthesis of antiviral and anti-cancer drugs, and these research programs were funded by the Cancer Research Campaign of the UK and the AIDS-direct programs of the Medical Research Council UK, the Leverhulme Trust UK, and Glasgow USA. He received an international credit for his recent work at the Cardiff University and also received an award from the Scientific Publication in 2013. Yes, sir. So this session is over now. Thank you.
So, you all are welcome for this session, pharmacy. Before we commence this session, I would like to introduce our judges for this session who are going to evaluate. Dr. Vera, Senior Lecturer, Department of Pharmacy and Pharmaceutical Sciences, University of Sri Lanka, and Dr. A.I. Kuruppu, Senior Lecturer attached to KDU Care, General Surgeon, Kotelawala University. I welcome you both. So, actually, before we start, we would like to the way how we conduct this session. Now, for a presenter, the speaker will get 10 minutes. 3 minutes will be given for each speaker for questions and answers at the end of the presentation. For first 8 minutes, once the first 8 minutes completed, the bell will be tapped once, and after completion of 10 minutes, the bell will be tapped twice. So these are the things actually we have to stick to the time, and 10 minutes, and out of 10 minutes, 7 minutes, and then 8 minutes, and then after that 2 minutes will be given for total of 10 minutes. So to start this session, I would call upon as the first speaker Mr. WGDC Jayanandana. Over to you. He will talk about anti-tyrosinase activity of green synthesized Silva nanoparticles from aqueous extract of Nelumbo, nucifera, Petals.
Very good morning to all of you. My topic is anti-tyrosinase activity of green synthesized Silva nanoparticles from aqueous extract of Nelumbo, nucifera, Petals. So I am Person WGDC Jayanandana and my supervisor, Dr. Abeysekera from the University of Colombo. Actually, I am a formulator of cosmetics, so this research project profession. So here are the contents. When we are talking about the cosmetic industry, it's one of the largest industry in the world. So according to the CNN reporters, they in 2020 all around the world they invest $8 billion for the cosmetic manufacturing and cosmetic research works. So they estimate it will be doubled in 2023. So among these vast variety of cosmetic products, so skin whitening cosmetics are one category of the advanced cosmetic, and it decreases pigmentation of the skin. Pigmentation of the skin is highly represented by the ingredient which is in the body, which is melanin. So melanin is produced in the melanocytes. So this melanogenesis is regulated by tyrosinase enzyme. Inside the melanocytes, there is a substrate called L-tyrosine. L-tyrosine is the starting material for the melanin. So tyrosine is a tyrosinase enzyme is the copper-containing enzyme that catalyzes vast variety of reactions inside the melanocyte. So when we are inhibiting enzyme tyrosinase, we can inhibit the production of melanin. So therefore, tyrosinase inhibitors have gradually become more important in medical and cosmetic products. As I mentioned in earlier, according to the R&D works we are done in the cosmetic industry, green nanotechnology is used many areas for the enhancement of the formulation. So because we use green nanotechnology, significantly contributes to environmental sustainability through the production of nanomaterial and nanoproducts without causing harm to human health or the environment. The rationale behind the utilization of plants in nanoparticle formulation is that they are easily available and possess a broad variety of metabolites, means secondary metabolites, such as phenolics, alkaloids. My research projects, I use Nelumbo nucifera, commonly named as sacred lotus or Indian lotus, for the reduction of silver ions to the silver nanoparticles. So these are the objectives of my project: to green synthesize and characterize silver nanoparticles from aqueous extract of Nelumbo nucifera petals, and to investigate the anti-tyrosinase activity of green synthesized silver nanoparticles. Let's move to the methodology part. You can see in the presentation, it's very simple apparatus setups I used to synthesize. I used to make my petal extract. There are three operating conditions. It's very simple apparatus setup. So this is the apparatus setup for green synthesis of silver nanoparticles. You can see in the burette I used burette to introduce petal extract to the silver nitrate solution. In this step we have to deeply consider about the operating conditions, because the temperature is highly important to maintain the particle size of the nanoparticles. So you can see the picture. The picture A is the Nelumbo nucifera petal extract, and picture B you can see the color reaction after the reduction process. So this is methodology for the tyrosinase assay. I used spectrometer to analyze the tyrosinase bioassay, and reaction mixture consists of tyrosinase as an enzyme L-tyrosinase as substrate, potassium phosphate buffer, and positive arbutin. It's a tyrosinase inhibitor used as the positive control and test sample for the assay. According to the methodology, absorption was taken at 490 nanometer immediately after adding the tyrosinase at 37 degrees of Celsius means room temperature. After the microblade was incubated at 37 degrees of Celsius for 5 minutes, I get the second reading at 490 nanometers. According to this equation, finally calculated tyrosinase percentage inhibition. So let's move to the characterization techniques part. I used 3 characterization techniques for the characterized Nelumbo nucifera extract and green synthesized Silva nanoparticles. For characterized Nelumbo nucifera extract, I used UV visible spectroscopy and FTIR spectroscopy. Additionally, these 2 characterization methods, I used SCM imaging for the characterized Silva nanoparticles prepared by green synthesis. So this is the results and discussion part. According to the UV visible spectrum of Nelumbo nucifera, you can see lambda max, 2 regions at lambda max at the 300 nanometers to 400 and 200 nanometers to 300 nanometers. Aromatic chromophores absorption in 250 nanometers and carbonyl chromophores absorption in 300 nanometers. Altogether, carbonyl chromophores conjugated with aromatic ring absorption is according into the 250 nanometer range. This UV spectrum results confirm the presence of the phenolic compounds. Later, I will characterize this petal extract by FTIR analysis to confirm these results. Here are the FTIR spectrums for the Nelumbo nucifera extract and Silva nanoparticles. You can see from the blue color spectrum, it is for the spectrum for Nelumbo nucifera, and red color spectrum for the Silva nanoparticles. After the reduction process, the transmittance is increased due to the reduction process. So here are the main characterized peaks for in the FTIR spectrum. According to this FTIR spectroscopy analysis, the polyphenol groups, means polyphenol compounds present in Nelumbo nucifera, we can say they are act as the capping and stabilizing agents during the formation of Silva nanoparticles. So this spectrum is for the UV visible analysis of green synthesized nanoparticles. Once I mentioned in the earlier slide, you can see red-brown color change occurs when Nelumbo nucifera extract convert into the Silva nanoparticles. So in this spectrum, Silva nanoparticles exhibit a UV visible absorption in the range of 400 to 500 nanometer range. Experimentally, I proved that green synthesized Silva nanoparticles reported broad peak at 435 nanometer range. So this is the scanning electron microscopic image for the synthesized nanoparticles. I synthesized 80 to 100 nanometer particles because the temperature I mentioned in the previous slide, temperature is highly maintained. So this is the results for the tyrosinase inhibitory assay. You can see green synthesized Silva nanoparticles have 56% 38% and positive control has 65% of inhibition. These are my conclusions. Anti-tyrosinase activity of the green synthesized Silva nanoparticles exhibits potential inhibitory activity, and since Nelumbo nucifera petal extract mediated green synthesized Silva nanoparticles can be suggested as potential novel cosmetic ingredients. So these are my references, and I would like to acknowledge all the parties engaged with me this research project. Thank you very much for your attention.
Thank you. Presentation is open for discussion.
This particular plant, is there any reason why you selected this plant rather than selecting another plant, and why the petals without the other parts of the plant?
According to the literature, Nelumbo nucifera has vast variety of uses in the Ayurvedic medicine. So, according to my field, actually Nelumbo nucifera stems, they are used as the anti-wrinkle. They demonstrate anti-wrinkle properties. So I quickly go through the literature and I selected this plant because of the properties of that plant.
Have you looked at the stem as well, or are you hoping in the future?
No, I just do the research for the petals.
Any reason why petals?
Because its availability.
Here you have used the water extract.
Yeah.
So, did you take the concentration of the extract? How about it?
I used 10 grams of petals in 100 milliliter of distilled water. I first go to the aqueous extract because in green synthesis we are prone to use we should minimize the use of chemicals. So first we try to get the results from the aqueous extract, then succeeded. So if it is not succeeded, we have planned to go to the isopropyl extract and further.
And we repeat the same process. So how to make sure the concentration of this water extract is same as before, just complete the 10 grams of petals?
Sorry.
How to make sure that if we repeat the same process,
Yeah.
how do you make sure that the concentration of the water extract is same as before, because now we had the repeatability and all should be the same. So how do you make sure that?
Actually,
Because
it's
you didn't check the concentration after the extract, no?
no, I repeated the process and I got same UV spectrum. So I think I got the results from weighing process and go through that. And not to confirm, I don't go to the any other experiment to confirm the concentration. I just did the UV spectrum analysis.
It's a fresh petals or?
Yeah, fresh petals.
Thank you very much. Please join me.
Thank you.
The second speaker is Miss Amna. She will be in vitro analysis of anti-inflammatory activity of Sri Lankan leaves, honey, aloe vera, their combination, and the development of a topical anti-inflammatory gel. Over to you.
Good morning, fellow judges, academics, authors, ladies and gentlemen. I am Amna and I am here today to present to you my research work titled The In Vitro Analysis of the Anti-Inflammatory Activity of Sri Lankan Bees Honey, Aloe Vera, their combination, and the development of a topical anti-inflammatory gel. So for some background on how and why we chose this topic, when we were looking for a research topic for our final year undergraduate research project, we stumbled upon this fascinating branch of science called apitherapy, that was entirely dedicated to the exploitation of the medicinal properties of bees' honey. Upon further reading, we realized that various types of honey and aloe vera have been individually studied for their anti-inflammatory action, and that honey and aloe vera have also been successfully combined to promote wound healing in diabetic patients and for several other therapeutic benefits. That is when the question arose whether combining locally available Sri Lankan bees' honey with aloe vera would have a beneficial effect on its ability to suppress inflammation. And if so, we wanted to go on to formulate a novel anti-inflammatory gel to treat inflammatory skin conditions. The general objective of our research was to investigate the individual and the combined anti-inflammatory effects of Sri Lankan bees' honey and aloe vera, and to develop a novel topical anti-inflammatory gel. To break this down into specific objectives, we wanted to analyze the individual anti-inflammatory activities of these compounds. We wanted to analyze the effect of lyophilization, also known as freeze drying, on the anti-inflammatory potency of aloe vera. Then we wanted to go on to analyze the combined anti-inflammatory activities and develop a novel topical anti-inflammatory gel whose efficacy and stability we were going to evaluate as well. Moving on to the methodology. For easy understanding, we have divided the methodology of this study into two wide parts. Let's have a look at the first one now, the evaluation of anti-inflammatory activities. So for the evaluation of anti-inflammatory activities, we started off with the individual activities and then moved to the combined activities. The individual activities were tested for honey, crude aloe vera gel and lyophilized aloe vera gel. And then we moved on to the combined activities in a 1:1 ratio for the combination of honey with crude aloe vera gel and the combination of honey with lyophilized aloe vera gel. To take a deeper dive at this experiment, we used the albumin denaturation method using diclofenac sodium as the reference drug, and all of the experiments were conducted in triplicate using a concentration range between 78.125 and 5000 micrograms per milliliter in a two-fold dilution series. To take you through a step-by-step walk of our experimental procedure, we started off with 2 milliliters of whatever the test substance was, and added freshly prepared egg albumin and phosphate buffered saline into this. This mixture was incubated at 37 degrees Celsius for 20 minutes before we gradually heated it up to 70 degrees Celsius, at which it was maintained for 5 minutes before it was allowed to remove from heat and allowed to cool to room temperature. Then the contents of each tube were measured for its absorbance at 660 nanometers using a UV visible spectrophotometer. The absorbance values thus obtained were substituted in this equation to calculate the percentage inhibition of protein denaturation, which was input into GraphPad Prism, a statistical analysis software, which helped us plot the dose response curves and in turn obtain the IC50 values of these compounds. Now that we have had a look at the first part, let's move on to the second part of the methodology, which involved the formulation, characterization and stability evaluation of the topical anti-inflammatory gels. So this is how the gels were formulated. We started off with the stock solutions containing of 3 different concentrations containing a 1:1 ratio of aloe vera and honey, to which we added carbapol, the gelling agent, and stirred vigorously until a uniform mixture was obtained. Glycerol, phenoxyethanol and triethanolamine were then added as excipients to get our final product, the anti-inflammatory gels, whose star ingredients were honey and aloe vera. The very first thing that we wanted to do after formulation of the gels is to see whether the gel was actually useful, to see if the ingredients retained their anti-inflammatory activity post-formulation. So for this we used the same method that was described earlier in this presentation, and we also made a set of diclofenac sodium gels using the same concentrations as the honey and aloe vera gels to compare against our gels as a control. We tested the gels in their original form, and also we diluted it in a 1:10 volume ratio and checked the anti-inflammatory activity again. That is when we moved on to characterization and stability evaluation, which was done at periodic intervals over a 60-day period. The parameters that were taken into account were the organoleptic properties, pH and spreadability. Moving on to the results and discussion, when you look at the individual activities from this concentration response curves, it is evident that the individual compounds, that is honey and brewed aloe vera, showed only moderate activities. However, when aloe vera was freeze-dried, it displays a much higher activity than its own brewed counterpart, even at the same concentrations. When we moved on to the combined activities, when honey was combined with brewed aloe vera, there is a slight increase in activity starting from 625 micrograms per milliliter. But when honey was combined with lyophilized aloe vera, there is a drastic improvement in the activity, in the overall activity starting from 625 micrograms per milliliter. This improvement is also evident when you compare the IC50 values of the combinations to their respective individual counterparts. These are the results of the anti-inflammatory efficacy evaluation of the gels. So, the general pattern that was seen is that with the increase in concentration, there was an increase in the anti-inflammatory activity. And at the first two concentrations, the honey and aloe vera gels showed a slightly higher activity than that of the diclofenac sodium gel, and it was the other way around at the 0.5% concentration. On the right, you see the diagram for the activities we obtained after diluting our gels 10 times. The results of the stability evaluation reveal that the organoleptic properties, including odor, texture, and homogeneity, remain constant throughout the study period. However, the color at certain concentrations seem to have slightly increased in intensity, which could be considered normal taking into account that our product contained natural ingredients. The pH remained within a stable range of 5 to 6 throughout the entire study period and so did the spreadability. At the end of the study, we were able to conclude that the individual effects of aloe vera and honey were only moderate, and that lyophilization or freeze drying drastically increases the activity of aloe vera. And when you look at the combined effect is much higher than the addition of the individual effects, especially when honey was combined with lyophilized aloe vera. And finally, the gels that were formulated were observed to be efficacious and stable within the study period. We also have certain recommendations for further studies like conducting in vivo tests, toxicity tests, and optimizing the formula, testing for other therapeutic benefits of this formulation, and comparing different types of honey from different regions, different floral sources, and again to play around with the proportions, because the proportion that we used in this study was only 1:1 due to a limited time period. We also would like to propose to study the mechanism of interaction between the two components. As a summary of today's presentation, lyophilized aloe vera alone and its combination with Sri Lankan bees honey reflect a promising potential to be exploited clinically with further research, owing to the fact that its concentration response curve comes really close to that of diclofenac sodium displayed in blue, which is already a widely used anti-inflammatory agent. And we believe that with further optimization and testing, that this product may have the potential to be useful in the treatment of inflammatory skin conditions. These are the key references of our study. And finally, I would like to take the opportunity to express my sincere gratitude to my supervisors, my research partner, the staff of the Department of Pharmacy, FAHS KDU, the Department of Medical Laboratory Sciences for allowing us to use some of their resources, Astron, Baraka, the Bandaranaike Memorial Ayurvedic Research Institute, and finally the organizers of the KDU IRC 2023 for this wonderful opportunity to showcase our research work. Thank you very much, and I'll be happy to take any questions.
Thank you, Ms. Amna. Open for discussion.
So, why did you find that the lyophilized aloe vera was much better than the
The reason that we haven't conclusively proved this, but what we think is that we started off with about 1 kilogram of the aloe vera juice. And at the end of the 10 days of freeze drying, we were left with about only 1% of the original weight. So we think it could potentially be an increase of the concentration. But we also think if a different method like heating was used, it could have damaged the anti-inflammatory properties. Since freeze drying doesn't involve heating, it could have retained certain components that are useful in the anti-inflammatory activity.
And also, have you thought of looking at any other experiments, like over here you used, I think, protein denaturation, and any other experiments? I mean, then you can compare probably the results.
Yes, so there are certain, like we came across the lipoxygenase, proteinase inhibition, and again the RBC lysis inhibition, but we were planning to do the RBC lysis, but we ran out of time. So we hope if we have time in the future to conduct that.
Thank you.
So can you please justify the reason for using diphenolic acid to city control?
Most of the studies that we had that we went through in our literature surveys had used diclofenac sodium, and the other thing is it was one of the drugs that was easily available. We got it through one of the pharmaceutical companies, so that was the easiest drug that we were able to get our hands on.
Yeah, but I mean that the mechanism with the again assay and the activity done through the diphenolic. So chemically or their reaction wise, so can you see what's the reason?
We tried to find out, but when we went through papers, there was no evidence or at a chemical level the interaction. So I'm not very sure about that.
Okay. So how did you obtain honey?
Honey was obtained from a commercial supplier.
How about the purity?
They gave us a certificate of analysis saying that it confers to the ISO standards and that it is from the wild.
Common.
Yes.
But you didn't go and collect
No.
it, no? So you just got the assurance from the supplier.
Yes.
So do you think that it's 100% accurate or?
As in the assurance.
Honey samples?
The honey
There
sample.
are different, even in the Sri Lanka, they have different types of honey samples, and there are so many variations. So then, how you can make sure that the sample is 100% pure?
Yes, so in one country, I don't remember the country exactly in a paper, they had standardized the environment and grown the beehives in a controlled environment. It was called RS honey. So they used that honey for the medicinal properties, so they were able to ensure that the quality and the proportions of the different components of the honey will be the same. So something like that, if it is financially feasible, would be the best thing to standardize our honey.
Thank you.
Thank you.
Next presenter is Ms. S.K. Sabalingam. She will talk about evaluation of excipient properties of starch extracted from Dioscorea, Angala, grown in Sri Lanka, and its suitability in the formulation of certain potassium tablet.
Good morning. Good afternoon, everyone. I'm Silva. I'm today going to present my undergraduate research under the title of Evaluation of Excipient Properties of Starch Extracted from Kahata, Dioscorea alata, grown in Sri Lanka, and suitable in the formulation of certain potassium tablet. So this is the content I'm going to cover here. First, introduction, justification, objectives, methodology, results, discussion, and final conclusion and recommendation. Let's move to introduction first. What are excipients? Excipients are any pharmacological event compound added along with the active pharmaceutical ingredient to enhance the final quality of the product, such as binders, disintegrant fillers. Starch is widely used excipient in pharmaceutical industry. Here we use Angala. It's a Dioscorea alata group tuber, which is grown in all ecological zones in Sri Lanka and with high availability and distribution. And also it contains 60% to 85% starch on dry basis. Its one of the major species which are cultivated in Sri Lanka. So you can see this is the plant of Kahata, then this is the yam tubers of Kahata. So why we selected this topic as our final year research? Because according to the annual info 2013 of SPC, the inventory's budget stated that highest expenditure for excipients such as commercial starches. Sri Lanka has varieties of natural sources. If the country is able to produce starch from our natural sources, it will reduce this total cost for importation of starches and production cost of dosage forms. That's why we wanted to introduce a new starch for pharmaceutical industry. That's why we selected this topic. So here we wanted to achieve several objectives. First, our general objective was to evaluate excipient properties of starch extracted from Kahata. And under that, we wanted to achieve several specific objectives such as to extract starch from Dioscorea alata and to determine its yield, and to characterize the physicochemical properties, and to analyze the proximate composition of extracted starch, and to formulate losartan potassium 50 mg tablet, and finally to evaluate quality parameters of those tablets. So let's move to the methodology of our research. First, we collected our yam tubers and fresh plant material from local farm in Kebol, and then we identified and authenticated that yam from Bandar Naik Memorial Ayurvedic Research Institute, Navin. And rest of pharmaceutical graded raw material were gifted by raw material stores of SPC. And this is the starch isolation process. For your easy understanding, I figure out them like this. First, we cut them into small pieces like this, and then we wash them with distilled water, and then we wash again with sodium metabisulfite to prevent darkening, and then again we cut them into small pieces like 2-3 centimeters, and then we ground them into starch slurry from laboratory blender, and then we filtered them through muslin cloth like this, and finally we sedimented them 3 days, finally to obtain dried starch like this. Then from this starch we check their identification test and we test their yield, and then we perform several tests such as organoleptic characteristics, light microscopic analysis, and IR spectrum scanning electron micrographs also. Here we test some physicochemical properties such as pH, particle size, bulk density, tap density, true density, angle of repose, Hosner ratio, compressibility, hydrogen capacity also according to British Pharmacopoeia. Then proximate analysis was done according to AOSE methods. All the above tests were carried out for as well for comparison. Then we prepared our tablets by wet granulation after modifying and optimizing the pre-remedy formula. This is the formula we use for tablets. You can see losartan potassium, lactose, dry starch, purified talc, magnesium stearate are ingredients. So then using this formula, we prepared granules first using 10% binder concentration using 150 mg patches, and then we prepared dried granules. Then we prepared tablets using our tablet machine, and then we evaluated organoleptic properties, tablet hardness, tablet friability, uniformity test, thickness, disintegration time, and dissolution test according to the British Pharmacopoeia standards. Here's the figures for your easy understanding. You can see these are the granules we obtained, and this is the tablets we prepared. And this is the very crucial part of our research, its results. According to the results, the percentage yield of Kahata was 13% to 15%, and both Kahata starch and maize starch provided dark blue color indicating the presence of starch in it. So this is the organoleptic properties of starches. You can see only difference is the color, because Kahata is light pink in color and maize starch is white in color. So this is the light microscopic analysis. You can see Kahata is having larger oval and truncated shape granules without hyla, and for maize starch smaller polygonal shaped granules with the hyla. This is the scanning electron microscopic analysis results. So you can see Kahata starch having larger granules with the mean diameter of 23.88, and for maize starch it is 12.97 micrometers. This is the physicochemical properties of both starches. You can see all the p-values are less than 0.05, indicating they are
significant difference with both starches. So this is the FTIR spectrum analysis. You can see both male starch and Kahata starch showing their peaks in 3000, 3500 and around 1000 ranges, indicating their starchy nature. And this is the FTR spectrum of losartan potassium BP with male starch and FTR spectrum of losartan potassium with Kahata Angala 1:1 ratio. Both indicate same structure. And this is the comparative evaluation of proximate analysis. You can see moisture content, crude fat content and carbohydrate are having larger p-values more than 0.05, indicating there is no significant difference with both two starches. So, from our formula tablets were round in shape, pink in color with smooth texture and no odor. But in those tablets, some parameters are fail from the standard pharmacopoeial standards, such as thickness, hardness, uniformity of weight, disintegration, dissolution, due to the machine we use, because we use single punch machine for that, and their compression force not under our control. So it has higher compressional force. But friability is within the range, indicating 0.7%. This is the discussion of our research. So Kahata has a similar appearance to male starch BP, only difference was color, but we can use decolorizing agent to minimize this effect. The physicochemical parameters of Kahata starch are not significant comparable to male starch BP. Kahata starch exhibited better flow properties than male starch BP in terms of angle of repose, Hosner ratio and compressibility index. And both Kahata and male starch BP provide a similar FTR spectra, and the moisture content, crude fat content and carbohydrate content of Kahata were found significantly comparable to male starch BP. Formulated tablets of Kahata starch did not meet the official compendium standards in weight variation test, hardness test, disintegration and dissolution test. Due to that, I previously told issues. So, in this is the final part, conclusion and recommendation. In conclusion, the study revealed that several parameters of Kahata starch are favorable as excipient as per the pharmacopoeial specifications. Certain parameters are similar to male starch BP as well. Further studies are required to improve the excipient properties such as disintegration dissolution and to ensure its suitability in pharmaceutical excipient. And further investigation with different binder concentrations of Kahata are also recommended. So these are the references we used for our research. And finally, I would like to extend my sincere gratitude to our beloved supervisors, co-supervisors, academic and non-academic staff of the Department of Pharmacy and the Director of Ayurvedic Research Institute and now in the State Pharmaceutical Corporation, Sri Lanka. Thank you everyone. Yeah, we wanted to perform, madam, but due to time permits, we didn't have enough time for perform the stability test, but we are to stability future studies.
Can you go back to the slide with the friability DT values of the tablet? The slide you showed with the parameters tenders for the tablet? Yeah, previous.
Yeah.
Did you check with the, did you prepare the tablet with the normal male starch to compare?
No madam, because in our previous literature they have performed, but we wanted to perform on our formula as well. But since our research is somewhat takes long time in extraction procedure also, we did not have enough time to prepare tablets from male starch BP. That's the reason, but in future studies we are to perform the mass.
Yeah, I think you must do, otherwise we can't compare because once we prepare the granules, it's according to the compression method, all the parameters can vary. So if you don't follow the correct compression method, in compressed tablets, mention that it has due to the error with the machine. So then we can't compare because machine error we can't consider. So then otherwise if we can compare with the standard with the, using maize starch BP, so then if we can see the same difference, then we can compare. Otherwise we don't know whether these issues are due to the starch we use here or due to some other reason. So I suggest you to compare both. Prepare the tablet with the commercially available maize starch as well as your own extracted starch. So then only we can see the exact difference and see whether we can use them or not.
Yeah.
Any questions from the audience? So thank you very much. Next presenter, Ms. LKDA Jayanandana, formulation of nano-suspensions of Cydium Java fruit extract and evaluation of antioxidant activity.
A very good afternoon, everyone. I wish your patience and attention for a few minutes. I'm Deviki Jayanandana. So this is the topic, formulation of nano-suspension of Cydium Java fruit extract and evaluation of the antioxidant activity. I think all of you heard about this fruit. In English we call it as guava. So it's contained numerous pharmacological properties, and out of them its antioxidant activity has been proven previously. So these are the main area I am going to cover with you all today. Objectives and the importance, a little bit about the background, methodology, results and the discussion, conclusion, recommendation and some of the references. So main objective is to formulate and characterize the nano-suspension which was prepared from Cydium Java fruit extract and evaluation of their antioxidant activity. So why it's important to us? Because bioavailability is the basic problem arising with the oral formulation. So this can be lead to formation of oral formulation which was synthesized from the natural product, especially to enhance the bioavailability. So when we come to the background, I think all of you know about the free radicals. So free radicals are the molecules having unpaired electron in their atomic orbitals. So this may lead to oxidation of our essential molecules like cell membrane, DNA and other essential molecules. So this causes to oxidation, and due to the oxidation there is a damage can be happen. It called as oxidative stress. Actually, this oxidative stress is not good for our health, especially it may lead to aging process and diabetic mellitus, heart diseases can be happen. So that's why we have antioxidants. So there are two types of antioxidant available, synthetic and natural antioxidant. But you know, if you use synthetic antioxidant for a longer time, it may cause gastrointestinal problems and also it may lead to cancers as well. Other than that, most dangerous side effects can be happen. So that's why we have natural antioxidants. So they are widely available in the nature, and the problem is we can prepare natural antioxidant, but they has not exert their maximum antioxidant activity in vivo because phytochemicals are hydrophobic in nature. So that's why we want to enhance this bioavailability of the Cydium Java of our fruit. So there are so many advanced technologies available. Out of them, nanotechnology was used in our research because nanotechnology we can maintain our particles is in the nanoscale range. So then we coming into the methodology part. Unripe Cydium Java fruit were collected from 6 provinces and they were washed, dried and peeled off. Then fruit were grated into the small pieces and allow them to dry. For that we use refrigerator. Actually, thereafter, the dried particles were grinded to form finer particles because it facilitates extraction process. Extraction was done by using solvent extraction and isopropyl alcohol as a solvent. Then total evaporation method was used as the evaporation method. So then, this is the most important slide because this tells you how did we formulate our nanosuspension. And normally, formulate the nanosuspension, we require two solutions. First one is organic solution, and other one is inorganic solution. Organic solution was prepared by dissolving our extract in 2 to 5 ratio containing acetone ethanol solution. So it placed to the burette as you see in the picture. And inorganic solution was prepared by dissolving distilled water with polymers. So in our research we used two polymers, those are PVP and the sodium arginate. So then these two mixtures was mixed using a magnetic stirrer. So this video shows you it properly. So it's not done well. So here actually we transfer our organic solution into the burette and inorganic solution to the beaker, and we maintain the rate of dripping organic solution to the beaker at 1 milliliter per minute. Simply 20 drops per minute. So then it's allowed to mix 15 minutes at the 25 Celsius and maintain the speed at 1000 RPM. So then initial part was done and 0.2 polymer and 50 milliliter of water filled to the burette and allowed to drip into the styrene solution. So the whole mixture was allowed to rotate at 500 RPM at 25 Celsius for a 6 hours. Then nanosuspension was prepared and then it's allowed to remove solvent to obtain the dried particle because these dried particles we use to scanning electron microscopy. So morphology and the morphology was basically characterized by using the scanning electron microscope. That's all about our methodology, nanosuspension formation part. And evaluation of the antioxidant was basically done by using these three tests: BPPH assay, FRAP assay and INNO assay. In here we formulate dilution series. Then the most important part, that is the result and discussion. So these are the CM images of the nanoparticles we obtain. So first one is the sodium alginate nanosuspension of psyllium guajava fruit, and second one is the PVP nanosuspension of the psyllium guajava fruit. So these are the results we obtain after evaluating the antioxidant activity. So I know at the very first time you think that only crude guava, that means blue color, only having a concentration dependent activity, but others are not. Purple color shows you the guava sodium alginate nanosuspension, while red color shows you guava PVP nanosuspension. But carefully look at, in here you may see at the very lowest concentration, both nanosuspension exhibit highest activity. For example, 77.59 for the PVP nanosuspension and 84.30 for the sodium alginate nanosuspension. So when compared to nanosuspension, again you can see sodium alginate having highest activity. So this suggested that sodium alginate nanosuspension is the best one. So when we come into the FRAP activity of the psyllium guajava, again crude guava as well as sodium alginate nanosuspension both having concentration dependent activity, but sodium alginate nanosuspension having minimum activity when compared to crude guava. But look at again at the minimum concentration, again sodium alginate nanosuspension exerts maximum activity. But when coming to the PVP nanosuspension, at the three possible lowest concentration, it exerts highest activity. So again, we can suggest PVP is the best polymer for FRAP activity in order to enhance the FRAP activity. So finally, NO scavenging activity of the psyllium guajava. Actually, these results are somewhat different than other two results we obtained. So basically in here, different concentration may exert highest activity. For example, for the PVP nanosuspension, it gives 6.82 in the lowest concentration, while sodium alginate show is in the 0.625 milligram per milliliter. But again, we can reveal that sodium alginate is the best one in order to enhance NO scavenging activity. So then finally we can conclude that crude psyllium guava fruit exert remarkable free radical scavenging activity in their crude form. But when we prepare them into the nano suspension using the two polymers PVP and the sodium alginate, actually exert the free radical scavenging activity and the antioxidant activity at the lowest concentration. So finally we can conclude that preparing the nanoparticles from seed of guava fruit exert the good antioxidant activity, and those are the recommendations we suggested. We can change the pH and repeat this test, and also addition some surfactant, change the temperature, change the polymer, because in our research we only use PVP and the sodium alginate, and we can change the rotation speed and again repeat this test. And especially we like to evaluate this test to check bioavailability in vivo studies as well. So those are some of the references, and I would like to thank my supervisor, co-supervisor and my group member, and especially technical officers and laboratory assistant of the Biomedical Research Laboratory 2 at the Faculty of Medicine and the Pharmaceutical Chemistry Laboratories, General Sir John Kotelawala Defense University. And also I would like to thank Faculty of Technology, Rajaratnam University of Sri Lanka for allowing us to use scanning electron microscopy. Finally, I want to thank my parents, family members and friends who helped me in a way in making this research project a success. So that's all about my interest. Thank you very much.
Thank you. Open for discussion.
So when you actually making your nanoparticles, how did you calculate the concentration of your plant extract?
So actually in the extraction process we use 100 gram of our fine powder particles with 500 milliliter of isopropyl alcohol. So that's the basic.
Did you find it in other literature? How did you come up with that concentration?
Yeah, we actually found, we read some literature review and we found that that is the possible concentration for that.
And the second question, in the DPP HSA, so you are saying that use PVP, low concentration will give you good antioxidant activity. Is there any reason? Can you justify?
So actually, madam, we made a concentration series. So we could see at the very lowest concentration our DPPH activity was high. So we think that when the concentration will increase, accumulation can be happen, and due to accumulation, this activity can be reduced, and thereby we can only see at the lowest concentration only the DPPH scavenging activity is high.
Related to the same question, I don't know whether you have seen this sort of activity, higher activity, lower concentration in other literature.
Yeah, literature we see. We see that we saw that especially when the concentration is increased, agglomeration can happen, and that's why we conclude also the same.
Right. So if you want to use this extract for further studies and for further formulation, so how you can work out with these low concentrations?
So actually we can we can make a concentration rather than the most possible lowest concentration of our result, and thereby make the concentration series and we can repeat the test again.
So you said that you have obtained samples from 6 different locations. So that's same variety?
Actually, madam, yeah, same variety. We collected from different provinces because some of the time geographical variations can be happen to our sample, and to avoid that and also to make a pool, we collected them from the different provinces.
So you check the combination, not the individual samples.
Yes.
Thank you. Congratulations. Miss T.A.T.M. Silva, she wrote comparative analysis for the anti-cholesterol activity and vitamin B analysis for polyphyllum
cholesterol level rather than communicable diseases. According to references, 2.6 million people die in a year due to the various kinds of diseases caused by high cholesterol level. And also we know that there are plenty of medicines available in the world in lowering cholesterol. Even though these medicines are very effective in lowering cholesterol, we know that they have some side effects. So, at the same time, we know that people are living in a developing country like Sri Lanka, getting a good quality medicine for a long time period is very difficult for them economically. So that we thought connecting with Ayurvedic medicine will be a very good advantage for our research. So, to explore the Ayurvedic traditional knowledge in order to develop kind of a good, effective solution in lowering cholesterol with the lesser side effects will be a solution for this matter. Then we selected these 3 plants because they have history of using Ayurvedic doctors in various conditions like hypertension, fatty liver and obesity. So we selected these 3 plants in our research. This is the general objective of my research, is to map anti-cholesterol properties and analyze the biochemical composition of these 3 traditional herbs. And then these are the specific objectives to conduct the solvent-solvent extraction using various kind of solvents, and then to evaluate the anti-cholesterol properties, and then to identify the phytochemical composition of these 3 medicinal plants using in vitro bioassays. Now I'll talk about the methodology of my research. At first, we collected fresh plant material and we dried them. Then we obtained the plant extraction using maceration extraction method using several various solvents which are having different qualities. Actually, this maceration extraction method is very easy and very cost effective to conduct, and also it helps to protect the volatile substances of the material. So we selected this maceration method for our research. These are the few steps. And then to evaluate anti-cholesterol activity, we selected the cholesterol reduction assay, also known as Lieberman-Berger reagent assay. Actually, it is a colorimetric assay. As a first step of this assay, we determine the maximum wavelength, and then we evaluate the anti-cholesterol activity of these 3 plants. We used as a simulus routine for the positive control for this assay. Then we analyze our results using graph baptism 9, and we evaluate them, we determine the most effective solvent in plant extraction when it comes to the anti-cholesterol activity. According to our results, it was methanol. So we proceed our phytochemical analysis with the methanolic extraction only. We quantitatively and qualitatively analyze both these phytochemicals. This is a list of phytochemical analysis tests that we have conducted. And now I will talk about our results. At first I will go with the cholesterol reduction assay. Actually, the cholesterol reduction assay, also known as Lieberman-Berger reagent assay, it is a colorimetric assay, as I mentioned before. The reaction between cholesterol and Lieberman-Berger reagent was produced a blue-green color compound. Actually, that was the main parameter for this assay. Actually, this reaction is very sensitive for the external environmental factors like light sources and temperature likewise. So to eliminate those kind of factors, we determine the maximum wavelength for this reaction to match with our working environment. According to our results, maximum wavelength is 400 nanometer. But according to the references, the maximum wavelength is 410 nanometer. Now I'll talk about the cholesterol reduction percentage levels. Before talking about our results, I would like to tell you there have been no scientifically proven studies conducted on the anti-cholesterol activity of these 3 particular species, but different species in biophytogenetics was studied for anti-cholesterol activity. Okay, with that, now I will talk about our research, our studies results. When comparing these 3 solvents, hexane, ethyl acetate, and methanol,
reduction level. When comparing these three plants, Anti-inflammatory plant has the highest cholesterol reduction level. So, botanic extract of Anti-inflammatory plant has the highest cholesterol reduction level. When it comes to the IC50 values are inversely proportional to the level of active compounds in the sample. As you can see, botanic extract of Santherium cinereum has the lowest IC50 value of 17.48. This is a graphical representation of the results that I will mention. At the first graph, the red line shows the methanolic extract of Santherium cinereum shows the highest anti-cholesterol capacity. Now I will move on to the phytochemical analysis. As this table shows, all these phytochemicals were detected in all the methanolic plant extracted. Interesting fact is, according to the references, these phytochemicals have been associated in lowering cholesterol. And we quantitatively analyze some of these phytochemicals, flavonoid, saponin and alkaloid. When it comes to the flavonoid and saponin, Santherium cinereum plant shown in blue color gives the highest total saponin content and total flavonoid content. When it comes to the alkaloid, biophyton growing white plant shown in ash color gives the highest yield. The conclusion. After analyzing our results, we came up with this conclusion. The methanolic fraction showed the highest level of anti-cholesterol activity and the highest anti-cholesterol capacity have been shown by Santherium cinereum plant. And phenol, saponin, alkaloid, tannin, flavonoids and sterols were detected in all the methanolic plant extraction. Now the recommendation. We have few recommendations for the future studies. We suggest to study, validate and the efficacy and the safety of these herbal extracts in large clinical trials. So this can solidify the scientific basis for their use in modern healthcare. And also we recommend to analyze and identify the specific compound responsible for the anti-cholesterol activity. So this knowledge can guide to develop the targeted treatment. And also we have recommended to emphasize the potential of herbal remedies from Ayurvedic tradition as alternative to synthetic medication for hyperlipidemia treatment. These are the references that I have used to make this presentation. And I would like to express my deep gratitude to my supervisors and my institute and my team members and all of you. Thank you.
According to your research, methanol extract is the best compared to other extracts. So, do we have any idea what is the reason for using your background knowledge and the literature survey?
Actually, ma'am, there are no other research conducted on this alcohol activity of these three plants. So we don't have any background knowledge about that. So I'm not too much sure.
So, you have used simvastatin as the positive control here. So, can you please explain the reason behind the using of this positive control?
Yes, ma'am, we follow the standard protocol for this Vitro assay. As mentioned, simvastatin is the positive control for them also, and also we know that simvastatin is a very effective medicine in a study group medicine lowering cholesterol, so we use that in ours.
According to you are correct.
Sorry?
You are in pharmacy?
No.
So this mechanism, do you have any idea of the mechanism of action of the simvastatin?
No, I'm suggesting.
So you have looked at 3 plants. So in the future, you think of combining, because sometimes it might be much better if you combine the plants and look at it. So also I think even the second speaker, when you're combining, I think you should look at number of ratios and then I know it's limited time for the research and all that. So look at number of ratios. Are you hoping to do something like that?
further questions? We could some more time. Yeah. Thank you very much. Next speaker is Mr. H.T.T. Madhulanka. The comparative study on the toxicity and biocompatibility of aqueous extract in various developmental stages of Silva.
Hello everyone, I'm H.T.T. Madhulanka and I'm from the Department of Biomedical Science, Faculty of Health Sciences, KIU. So today's subject topic was a comparative study of the toxicity and the biocompatibility of Hemideosmus indica aqueous plant extract in various developmental stages of zebrafish using the FET 293 bioassay according to the OECD guideline as well. So moving to the little bit of introduction and background. So the modern world tend to discover herbal remedies and medicinal plants are an important source of obtaining various drugs and active metabolites. So Hemideosmus indica, commonly known as Iramusu, is widely used in traditional medicinal system in Sri Lanka, and the local populations use this as the herbal tea as well. Hemideosmus indica belongs to the family Abeysekera, and it is a plant with long and slender roots, simple, short petiole leaves with striated down middle with white color, and flowers are small and dull yellow to deep with purple in color. So there are several uses of Hemideosmus indica such as skin diseases, dysentery, syphilis, lymphedema and all. So according to the previous literature, majority of the studies based on Hemideosmus indica were conducted by using the root extract of the plant. As the initial step of introducing the herbal plant extract to the use of medicinal drug, it is essential to determine the biocompatibility and the toxicity values of this plant extract is very important. So with that background, moving to the objective of this study, the major objective of this study was to investigate the biocompatibility and the toxicological properties of Hemideosmus indica aqueous plant extract using zebrafish embryo assay, FET 293 bioassay according to the OECD guidelines. So when moving to the methodological assessment, so in methodology, so the study design was the experimental in vivo study design. So study setting was the research laboratory of the Department of Biomedical Science, the Faculty of Health Sciences, KIU. So estimated duration of the study was 1 year. So data analysis, for the appropriate analysis of data, the scientifically validated gram-fat prism-9 software was used, and using the keywords such as biocompatibility, the Hemideosmus indica, toxicity, and zebrafish embryos, the literature survey was carried out using the PubMed, Google Scholar, and Dinari databases. And then the ethical consideration was, the ethical approval was obtained from the Ethics Review Committee of the KIU. So according to there are 2 phases, and the first phase was IRC phase 1, the in vitro lab studies, and the IRC phase 2 for the animal experimentation in vivo. So in plant material preparation, so Hemideosmus indica plant were collected from Colombo district, Western province, Sri Lanka, and then the plant was authenticated by Bandaranaike Memorial Ayurvedic Research Institute, Navi in the Maharagama. Then the samples were thoroughly washed, cut into small sections and air dried, and the plant material was extracted using the maceration technique, and after that filtering with 3 layers of muslin cloth, and it was allowed to the water to evaporate and obtain the aqueous extract powder. So then the plant dilution series was prepared according to the 2-fold dilution series, and 1 gram of plant aqueous extract powder dissolved in 1 milliliter of distilled water, and starting from 1 to 1.9 times 10 to the power minus 3 grams per milliliter concentration. So here you can see the authentication letters as well. So as I mentioned previously, collection of plant material, authentication and preparation of plant extract was performed. Then the preparation of the plant dilution series, and next step was the in vitro toxicity assessment. So basically, the brine strip lethality assay was performed. According to that, LC50 values we determine the concentration range and perform the zebrafish embryo assay FET 293. So
in toxicity and biocompatibility testing, moving to the brine shrimp lethality assay. So cultivation of brine shrimps was performed according to standard protocols, and 24 hours old napuli were used for our experimentations. In plant dilution series preparation, as I mentioned previously, we prepared using two-fold dilution, and 10 larvae were exposed to the different concentration of plant extract for 24 hours. So then the mortality percentage was calculated according to this equation, and the resultant LC50 was compared with the Mayer's or Clarkson's toxicity scales, which describes if the LC50 was less than 1000 micrograms per milliliter, which is considered as the toxic, and if the LC50 values are greater than 1000 micrograms per milliliter, which was considered as non-toxic. So all the study was replicated. So in zebrafish embryo fate 293 assay, the maintenance of adult male and female white-tailed zebrafish according to the appropriate protocols with the consideration of OECD guidelines. So the white-tailed male and female zebrafish were maintained at 27 degrees Celsius. pH, nitrates, nitrites and ammonia levels were monitored weekly by using the strip method, and the breeding tank was prepared. In breeding tank setup preparation, we obtained the zebrafish eggs, then incubated eggs at 28 degrees Celsius until the assay was initiated. So that according to the time points 48, 54, 72, 80 and 96 hour post-fertilization point, observations were made such as hatching rate, the mortality rate, survival rate, heart rate and the developmental deformities were observed. So this slide shows how the experimental setting was prepared. So this image shows how we are maintaining the anti-flow treated water treatment for all the assay conduction and the zebrafish maintenance. And this image shows how we are maintaining separate tanks for the male and female fish as well. So this is our simple breeding tank setup. So this is the schematic diagram, and especially this worksheet used for the data recording process, which is OECD guideline accepted and MRI accepted data sheet for the data recording as well. So then when we move into the results and discussion, so here with the consideration of brine shrimp assay, the highest mortality, which was 100%, was observed among 63 times 10 to the power minus 3 to 1 grams per milliliter concentration. The resultant LC50 was 48.2 milligrams per milliliter concentration for the aqueous extract. Then, by considering this LC50 value, we decided on the concentration range for the zebrafish embryo assay to evaluate the further toxicological effect and toxicological concentration of the Hemidesmus indicus aqueous plant extract. The resultant from the plant extract has not shown any toxic properties according to this Mayer's or class toxicity scales in brine shrimp lethality assay. So, when moving to the results and discussion of zebrafish embryo assay fate 293, so this graph showing the hatching rate, the hatchability of the zebrafish embryo. By observing these results, we can get a brief idea about how the fish embryos, the physiological enzyme levels or physiology effect using in this plant extract Hemidesmus indicus. So here the wild type zebrafish embryo at 24, 48, 54, 72, 80 and 96 hour HPF after exposed to various concentration of Hemidesmus indicus plant extract were shown here. So towards the highest concentration, the hatchability was increased, we can see. So the maximum hatchability, which was shown at the 96 hour HPF, 8 milligrams per milliliter concentration. So when we move into the, when we consider about survival rate percentage of the wild type zebrafish embryo who exposed to the same Hemidesmus indicus aqueous plant extract, which also shown towards the highest concentration, the survival rate also decreased. At the 72 hour HPF, 63 and 125 milligrams per milliliter concentration, statistically significant because all the larvae were dead. So, with the consideration of heart rate, we can get a brief idea about the cardiovascular toxicity level of the Hemidesmus indicus Aqueous plant extract. So here, all the results were shown, all the concentration series shown the normal heart rate within the range, which was 126 to 136, and which conclude the Hemidesmus indicus Aqueous leaf extract has not any cardiovascular toxicity effect. So, with the consideration of the developmental deformities, here we are evaluated. There are 4 types of deformities: non-structural deformities, then pericardial edema, spinal cord curvature, and yolk sac edema. So, according to the results observed, there are 100% yolk sac edema was observed within 31 milligrams per milliliter concentration. So, according to Silva assay result, the Hemidesmus indicus Aqueous plant extract toxic concentration start at 31 milligrams per milliliter concentration and above. Therefore, the study using Hemidesmus indicus method revealed. So, our Hemidesmus indicus Aqueous plant extract at 31 milligrams per milliliter concentration showed some toxic activities. So, as the conclusion, in the zebrafish embryo assay, the hatching rate was increased towards the highest concentration, the survival rate was decreased towards the highest concentration, the heart rate of the embryos remained within the normal range, and the mostly observed deformity was the yolk sac edema, which was 100% at 31 milligrams per milliliter concentrations, and the other than that, pericardial edema and spinal cord curvature were observed. So, there are some implications and future recommendations as well. Determining the biocompatibility and toxicity of Hemidesmus indicus is crucial for ensuring its safe use in medicinal preparations and can formulate the dosages. And we can formulate some herbal preparations such as wound healing gel, toothpaste and all. And we can perform phytochemical enzyme analysis to identify and quantify the active constituents of present in Hemidesmus indicus plant as well. So those are the main implications and future recommendations. So these are some important references which we use in our study. And finally, I would like to acknowledge my respective internal and external supervisors who provide us as a valuable guidance towards the success of this study, and as well as they acknowledge the KIU undergraduate research fund as well. Okay, finally, thank you so much for the opportunity.
Why you chose this Hemidesmus plant rather than any plants?
Yes, of course, ma'am. Hemidesmus indicus is a very important medicinal plant. Local population which use as a herbal tea, and as well as for which is used for the anti-inflammatory medication in the normal Ayurvedic preparations, and as well as the use in some neurotropic as well. So that's why we are using this plant to evaluate its general medicinal properties and its basic toxicological properties to this extract.
Now, in your methodology, you use the oat extract. So then, did you freeze dry it before?
No, madam. Actually, we are using the maceration method. So, in maceration method, we use one part of plant material dissolved in 3 parts of distilled water, and then let the mixture to settle in 48 hours. Then, using 3 layers of mustard cloth, we filter the extract and let the water evaporate in the fume hood, and then we obtain the aqueous extract powder.
Now, when we consider this plant in Ayurvedic system, we use in different formulations. So, like some can use for decoctions, and some may use the preparation method in Ayurveda vary according to the formulation or the dosage for the purpose of use. So then here you use maceration, but if we use it in another way, the preparation method is different. So do you think that the toxicity level will change?
Yes, sometimes it may be changed. So I hope to do a research in the near future by using the boiling extract and all, and using some hexane and phyllostate with like extract as well. And I want to compare these things and express my result.
polyherbal hand sanitizer.
Good afternoon, Chairperson and panel of judges and everyone. So, I'm Jayanandana. I'm going to present my research project formulation, characterization and evaluation of the antibacterial activity of polyherbal hand sanitizer gel. These are the contents. So, introduction. Hand hygiene is a significant principle that involves the prevention, control and reduction of infection. Hand sanitizers are used to maintain hand hygiene. So these days everyone knows about hand sanitizers and most of them are in alcohol based. So there are many drawbacks of these alcohol based hand sanitizers. So researchers are tended to preparation of polyherbal hand sanitizers. So in this study we take an effort to formulate polyherbal hand sanitizer gel using Petals, America and Nicholas artists. So these are the objectives. Our general objective was to formulate, characterize and evaluate the antibacterial activity of polyherbal hand sanitizer gel. Under this topic, there are several objectives to determine antibacterial activity of Aqueous extract of Dioscorea flower, Phyllanthus endocarpus and Ethylene extract of Nanoparticles and formulate the gel test and formulate hand sanitizer gel using different ratios of Aqueous extract of those plants and Ethylene extract of Nanoparticles and to evaluate antibacterial activity of formulated hand sanitizer gel against E. coli and Staphylococcus and to evaluate physicochemical parameters and stability of the prepared base efficacious gel formation and to determine the minimum initial concentration of the polyherbal hand sanitizer gel. Methodology. So, dried flowers of Abeysekera, dried flowers of Nicholas artists and dried fruits of Phyllanthus umbilica were used as the plant materials and plant authentication was done. So, in order to prepare good plant extract, we use decoction method for Aqueous extract and maceration method for the ethyl acetate extract and dilution series were prepared by two-fold dilution method. So, antibacterial assay for individual plant extract, gram-positive Staphylococcus aureus and gram-negative E. coli were used as the bacterial samples and to evaluate antibacterial activity, well-diffusion method was used. So this is the preparation of plant combination. We prepared 4 different plant combinations which were M1, M2, M3 and M4. So this is the preparation of blank gel. Blank gel means the gel without containing any plant materials and these are the ingredients: couple 940, glycerine, triethanol amide, distilled water and 95% ethanol. So these amounts were selected doing several pilot studies. So first couple dissolved in the distilled water and add 2 to 4 drops of triethanol amide. Then prepare gel was kept for 24 hours continuously. After 24 hours add 95% ethanol and finally add glycerine. So this is the preparation of antibacterial polyherbal hand sanitizer gel. First alcohol dissolved in the distilled water and Phyllanthus umbilica and Casia aculeata were dissolved in the distilled water separately. Then mix them together and add TE was dropically until gel was formed and kept 24 hours to sweat completely. After 24 hours, glycerine and after 24 hours add N-naphthalene extract and 95% ethanol and add glycerine. Then evaluation of gel characteristics. Characteristics of gel formulation were examined throughout 3 months. Gel characteristics such as color and odor were analyzed in 3 different temperatures: room temperature 4 Celsius and 37 Celsius, and pH and spreadability were analyzed. And as antibacterial effect evaluation, well diffusion method and microdilution method was used to determine minimum initial concentration. So moving to results and discussion. So this is the in vitro antibacterial activity of single plant extract, and this is the diameter zone of inclusion diameters of coli. And you can see N-tyrosinase has maximum activity than other two plants. And also this is for the Staphylococcus aureus. N-tyrosinase has maximum activity than other two plants. So this is the effect of various extract against the growth of bacterial species. Then in vitro antibacterial activity of plant combinations. So I told we prepared 4 combinations, M1, M2, M3 and M4. According to the results, M2 has showed maximum in antibacterial activity compared to other 3 combinations. So preparation of polyherbal hand sanitizer. This is our prepared gel, initial gel base. This contains charcoal 940, distilled water and only triethanol and kept 24 hours at room temperature to sell completely. After ethanol and glycerine. So this is the prepared gel base. After this is the prepared polyherbal hand sanitizer gel. So for that we prepared M1 combination, which was 1 part of Phyllanthus indica, 1 part of Cassia isolata and 1 part of Ictus artists. Then evaluate the characteristics and antibacterial activity of both formulations. The characteristics of blank hand sanitizer gel. So initially it has no color and transparent and appears as soft gel and there is no any odor. After 90 days, after 6 days, the gel was kept at 4 Celsius and room temperature remained as same as the initial stage. This is the characteristics of polyherbal hand sanitizer gel. So after 90 days, the gel was kept at 4 Celsius, remained as unchanged as initial stage, and the gel was kept at after 60 days. The gel was kept at room temperature, remained as unchanged at like initial stage. So initial stage it has light brown protein mixture and uniform appear soft gel. So this is the pH evaluation and spreadability information. So blank gel has increased pH than herbal gel and also spreadability is increased than herbal gel. In vitro antibacterial study of polyherbal hand sanitizer gel. So for that verification method was used. So you can see we test two concentration for both bacterial species and the form of inhibitions are very close. So we can assume prepared herbal gels inhibit the growth of both bacterial species, and there were no any inhibitions on for the blank gels. So minimum inhibited concentrations, we prepare several concentration of gels and we take absorbance and plot this graph. This is for the coli and this is for the Staphylococcus aureus. According to the results, blank gel has not shown any inhibitor reaction against growth of coli and Staphylococcus aureus, and minimum inhibitor concentration of prepared polyherbal hand sanitizer gel against Staphylococcus aureus was 18.75 mg per ml and E. coli was 9.375 mg per ml. Conclusion part. All these selected plant extracts have demonstrated antibacterial activity against Staphylococcus aureus and coli, and ethyl acetate extract of N-tyrosinase flowers has the highest antibacterial activity against both bacterial species, and M2 combination shows maximum activity compared to other 3 ratios. The polyherbal hand sanitizer gel formulation has remarkable antibacterial potency than the blank gel formulation. The pH of the polyherbal hand sanitizer gel was 5.8, which is an acceptable in pH range and demonstrates overall satisfying spreadability properties. Homogeneity, color, etc. were retained about 60 days at room temperature and 90 days at 4 temperatures. Taken together, herbal hand sanitizer based on Cassia isolata, Phyllanthus indica and N-tyrosinase could be a promising candidate for hand sanitation some differences, and I must be grateful to our research supervisors and my research partner and all the people who support us. Thank you for the listening.
Thank you. Open for discussion.
In this study, how you determine the combinations? You said you have used different ratios. So how did you determine this ratio? What is the basis behind?
Actually, we went through some research articles. So they were prepared some these kind of combinations, but we couldn't find any specific method to determine combination. So accordingly, we select that way.
That means randomly select.
Yeah.
So what now? If you want to improve this further and to identify better ratio, so what is the suggested method? What do you think? How you can find the correct combination? If you want to do further develop this study.
Actually, we only followed about antibacterial studies, but there should be lots of studies like about chemical part, spectroscopy methods, and those things. I recommend it.
Why did you take the individual activity first before you go for the combinations?
Actually, we want to check in case of making combinations, we want to determine what plant has most increased antibacterial activity. So that's why we done this.
But you didn't do the right. You did for the combinations.
Yeah.
So in your study, is there a reason why you chose ethyl acetate as the organic solvent?
Initially, we done antibacterial activity using aqueous extract of Nyctosaphrisis, but there were no any antibacterial activity. So we went through research articles and we select some solvents. So it mentioned methanol, ethanol has increased activity other than ethyl acetate, but we want to remove ethanol, so we can't use ethanol as a solvent, and methanol has some toxic activity, so therefore we choose ethyl acetate.
And in your individual plants, I think you saw good activity in Na, is that right?
Yeah.
But in your combination, it was a little different. Any reason? In the combination, I think it was 2:1:1, and then it was a different plant which was giving better. Is there any reason for that?
It may be the reason maybe extract of Phyllanthus embolica and extract of Cassia may reduce its activity. I think this can be the reason.
Thank you.
Congratulations. So the pharmacy session of IRC KDU will comprise of 7 praiseworthy presentations come to an end. So I can say all presenters contributed very well in their fields of drug discovery, drug delivery, and drug formulation. I convey my heartiest congratulations to them, and hope you will continue your research and also make an attempt to publish your results in good scientific journal, impact scientific journal. That's what it was pointed out at the last scientific sessions, symposium, and keynote speaker, that is what he actually suggested. And I wish you all the very best for our presenters, for their future endeavors. And also I convey my sincere gratitude to our judges, Madams, Dr. H.M.D.R. Vera, and also Dr. A.I. Kurupu for your useful contributions and your suggestions. Right, and thank you very much. But also, I thank all the staff who contributed to make this event a success. Wish you all the very best.
Thank you, sir. Ladies and gentlemen, we would like to warmly welcome the Deputy Vice Chancellor, Defence and Administration of General Sir John Kotelawala Defence University, Brigadier D.C.A. Vikram Singha, for the certificate awarding ceremony of the session. Ladies and gentlemen, we have arrived to the end of the technical session of the Department of Pharmacy. Now, I would like to cordially invite the Chairperson of the session, Senior Professor R.N. Pathirana, accompanied by the Head of the Department of Pharmacy, to award the tokens of appreciation to the presenting authors. To receive the memento, let me now call upon to the stage Mr. WGDC Jayanandana, Ms. A.S.S. Amna, Mr. S.A.N.C. Samarasinghe, Ms. S.A.N.C. Samarasinghe, Ms. L.K.D.N. Vijayawardena, Ms. D.A.G.M. Silva, Mr. H.D.T. Madhuranga, and Ms. M.R. Jayawardena. Thank you, sir, and please do remain on the stage. Now, I invite Senior Professor R.N. Pathirana to present the tokens of appreciation to the panel of judges. To receive the memento, I would like to call upon Dr. H.M.D.R. Herat, Senior Lecturer, Department of Pharmacy and Pharmaceutical Sciences, University of Sri Jayanandana. Next, I invite Dr. A.I. Kurupu, Senior Lecturer, Care, General Sir John Kotelawala Defence University. Thank you, sir. Now, I cordially invite the Deputy Vice Chancellor, Defence and Administration of General Sir John Kotelawala Defence University, Brigadier D.C. A. Vikram Singh, to present the token of appreciation to the Chairperson of the session. And I would like to respectfully invite Senior Professor R.N. Pathirana to accept the memento. Thank you, sir, for doing the honors. On behalf of the organizing committee, I would like to extend our sincere gratitude to Senior Professor R.N. Pathirana for chairing the technical session of Department of Pharmacy, and special thanks to the panel of judges, presenting authors, and each and every one of you who are present here today. Before winding up the session, here is a small announcement to all of you. Ladies and gentlemen, I would like to invite the panel of judges, the Deputy Vice Chancellor, invited guests, academic staff, and all the presenting authors, together with the authors, to join us with the lunch in the cafeteria, ground floor, Faculty of Medicine. And with that note, the technical session 2 of the Department of Pharmacy, Faculty of Allied Health Sciences of the 16th International Research Conference of General Sir John Kotelawala Defence University comes to an end. Sri Lanka Mata, Appa Sri Lanka, Namo, 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 Namo Mata, Sundar Siri Barini, Surandi Akisobamana Lanka. Palaturu Piri Jaya Bhumi Amna, Apahata Sarva Siri Siddha Sadhana, Jivanaye Mata, Irikadu Mena Apavakti Puja, Namo Namo Mata, Appa Sri Lanka, Namo Namo. Thank you everyone for joining, and have a pleasant day.